Let's go over the example 9.3 found on page 384. It says to complete these SN2 reactions showing the configuration of each product. Okay, it's telling you that they are SN2 reactions. And we know that for SN2 reaction, we will have the inversion of configuration. Why? Because if you take a look at the mechanism for SN2, as the leaving group goes away, the nucleophile is attacking the substitution center, this carbon, with a partial positive charge from the opposite side. So that's why you have the inversion of configuration due to that backside attack. So let's take a look at A. Let's identify which one will be the leaving group. This halogen here is your leaving group, and this is your nucleophile. Well, let's take a look how this nucleophile looks like if we are going to show the line formula. CH3 carbon, and we have two oxygens. One of them is going to have a negative charge, so 3 lone pairs, and the other oxygen does not have that negative charge. So we are going to place 2 lone pairs, and we will have 1 double bond. So this is your nucleophile. This is the substitution center, meaning we are going to change the configuration. So right now it's at the back. So for the product, that substitution center will be on the opposite configuration, now to the front. And we will have the nucleophile. This oxygen is this oxygen here. And then that's it. If we want to show the lone pairs, that is what you will have. But keep in mind, when you are doing the line formulas, you do not have to show the lone pairs. But for now, just to show you how many lone pairs you have, I am showing that. And this one right here, we are not going to change the configuration of this chiral center because that wasn't the reaction side. So we're just gonna leave it the same. You do a line formula, you can leave it just like this because this means that you have a CH3 here. And then you will just have this as the product. Before, for the starting material for the reagent, you have R and R for both chiral centers, but now here you will have R, but this one will be S, will be the opposite. You will have the inversion of configuration. Let's take a look at B. Again, this is SN2 reaction, and for SN2 reaction, we have the inversion of configuration, meaning that you will have this, instead of facing you, will be at the back. Count the carbons, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. And this will be facing the back. And instead of R, this will be S. This is your leaving group. And again, it's a nucleophilic substitution. So you will be replacing your halogen with the nucleophile. What is the nucleophile? But keep in mind here that for this nitrogen, you have 1 lone pair. And that is where you're going to be connecting this nucleophile to these carbons. So nitrogen, what is attached to this nitrogen? So you have 2 hydrogens and you have a CH3. And because now you will have 4 bonds for that nitrogen, you will have a formal charge of +1. And then to counter the balance, you can just show here the leaving group with a negative charge. But for both of these reactions, you will have the inversion of configuration. If the chiral center was R, now is S. Same here, if it's R, now will be S. It will be the opposite configuration because for SN2, you have the inversion of configuration.